Welcome, 7th grade. We're going to do 7M3 lesson 17 and maybe a little bit from 18. We are going to be talking about how we find areas of circles and pieces of circles and shapes that contain circles. So let's get over to our sketch pad and look at 3 problems that are directly from the, these are directly out of 7M3 lesson 17 and 18. So again, 7M3 lesson 17, 18, and we're talking about areas of circles. So the first thing I want to do is I just want to say we can use calculators. So calculators, we're going to use calculators, okay. That's point number 1. Point number 2, we're going to not use 22/7. Instead, we're going to use 3.14, which are both, these are both just approximations of pi. These are both approximations of pi. And pi is that magic relationship between the circumference of a circle, the distance around a circle, and its diameter. So if you have a circle and you know its diameter d, then you know that the distance around that circle, the circumference is equal. The circumference is equal to pi times d. So 3.14 times the distance across is the distance around a circle about. That's our approximation. So let's look at this problem here. Well, first of all, let's look. There's a formula, and we showed this in class, and I'm not going to get into this in the video, but that the area of a circle is equal to pi r squared. Pi times the radius squared is equal to the area of a circle. And again, why this is true is explained in lesson 17. We also looked at it in class and saw that it's pretty close to true. We took a circle and we laid some squares over the top of it, and we saw that it is about, it's really close to 3.14 times the radius squared. But again, I'm not going to show you why this is true. We're just going to use this formula. So let's start with the problem number 1, and then exercise 1, then example 1. Then we're going to do this problem number 4 that are, again, they're in lesson 17 and 18 in various spots. So we'll start easy and go to harder. So this circle here, it has a diameter of 21 centimeters, and we want to know the area. And we're not going to use 22/7. We're going to use 3.14 to approximate pi. So if our diameter is 21 centimeters, then our radius is half of that. And we've looked at that. So the radius, again, our radius is just half of this entire distance. So our radius is then 21/2, or 10.5 centimeters. So if our radius is 10.5 centimeters, then we now have what we need to find the area of the circle, because we just simply say, we use our formula, area equals pi r squared, which is equal to, and we're going to approximate. So we use this approximate, so this is the approximation sign. Approximation. Why does this write weird sometimes? Approximation sign. Not exact, but we're going to squiggle it like that. And that means because we're going to turn pi into 3.14, and so our answer isn't exact. It's close. And r squared is this 10.5 squared. Now, someone in class made a mistake, and they said, well, 10.5 squared is 10.5 times 2 equals 21, and that's not true. 10.5 squared means 10.5 times 10.5. That's what squared means. You have a squared symbol on your calculator. If you don't know how to use it, you can simply say 10.5 times 10.5, and we could say, we'll show that here, 3.14 times 10.5 times 10.5. And I'm going to just type that into my calculator, and I'm going to get our answer, and our answer is 346.185. I'm not going to put that in because we're just approximating anyway. Centimeters squared. Now remember our units, if our radius, our distances, you know, a distance is just centimeters, but when you're talking about area, you're talking about square units, and we explained that in class today as well. So the answer to number 1 is 346 centimeters squared. We just use our formula. We didn't quite know our radius, but we could get our radius from our diameter. And we'll just call that one done, and we'll go happy cat on that one. And now we're going to come back and try example 1. Now, here what we do, here the whole key is to figure out what is it that we have here. This is a half circle. This is half of a circle. It's not the whole circle. So the area of a whole circle is pi r squared. The area of a half a circle, you have to find the area, you know, to find area of semicircle, half a circle, you find the area and divide by 2. So let's do that. What is the area? What would the area of this circle be? Well, again, we have the diameter is 14. And so the radius is equal to 14 over 2 equals 7. So the area of the entire circle, if it were a whole circle, would be roughly, we'll put our squiggle signs in here, 3.14 times 7 squared. And that equals, do this on your calculator, make sure you know how to do it, 3.14 times 7 squared equals about 153.86, but I'm going to type in 154 centimeters squared. Now that's the area of the whole circle if it were a whole thing, but we're only talking about half of the circle. So the area over 2 is equal to 154 over 2, or 78. Sorry. 77 centimeters squared. Again, remember, you got to divide by 2. We're not finding the area of the whole circle. And so let's go happy cat on that one. Good job. And now I'm going to solve this last problem. And the last problem, I'm going to erase this stuff on the right so we have some space to work. So this is called a compound problem. So we have to do a few things. So notice what we're trying to find. We're trying to find the area in this rectangle. If this is, so we have a few key points. So we know it's 7. This is 7 from A to F. And so from A to H, because this is like a piece of a circle, we know that this is also 7 because this is our center. And this will be a radius here. Similarly, here we have 7. This is 7. That's our radius of this circle. And we know that FB is 9. So we know that from here to here is 9. And from H to D is 7. Okay, and so we're not going to use this. We're going to use 3.14 for pi. Okay, now here's the key. The way that you find, and what we're trying to find here is this area here, everything in between these two circles. So we're trying to find the area of the entire rectangle minus the 2 cutout quarter circles. So we're going to be looking at problems in these units where we find the areas of things by either adding or subtracting pieces. Let's just look at a quick example here. If this was a semicircle and this was a square, and we wanted to find, this looked kind of like a key in basketball, but if we wanted to find the area of this whole thing, we'd find the area of this, the semicircle, and the area of the square, and we would add them together and we would find this area. But in this case, we're looking at a problem where we're going to find the area of this rectangle and we're going to subtract off. Let me just make this, we'll make this in red, and we're going to subtract off this piece. We're going to subtract that out. So our strategy is to first find the area of the entire rectangle, and then we're going to subtract these 2 quarter circles. So let's find the area of this whole rectangle. The area of a rectangle, and we know this from long ago, is equal to the length times the width. Okay, so that's what is the length of this rectangle? The length, well, if this is 7 and this is 9, the length is 16. And the width is 7 plus 7 is 14. And so our area of that whole thing is 224 square feet, because these are all in feet. Okay, so that's the area of our rectangle, but now we have to subtract off these 2 quarter circles with a radius of 7. So, well, the quarter circles, if I could find the area of a circle, let's find the area of a circle. Let's do this in blue. If I find the area of a circle with radius 7, and I divided it by 4. So we're going to find the area of a circle that has a radius of 7, and we're just going to divide it by 4, and that's going to be the area of this piece here. So let's do that. So we're going to say, well, that's pi times 7 squared divided by 4, and that's going to be this piece. So let's approximate that, because the problem says we can approximate it. So let's approximate it and do 3.14 times 7 squared over 4. And let's see what that comes out to on our calculator. So I'm going to type that into my calculator. And I get about 38.5. I'm not going to round it just, well, I'm going to round it a little bit. We're going to call it 38.5. So this piece here, again, is 38.5. So let's just kind of redraw this a little bit. Whoops. Let me just erase this guy right here. All right, good. So we have a kind of straight lines, and we have this piece here and this piece here, and this isn't perfectly to scale, and it's really hardly to scale. But anyway, we'll say that this piece here was, this whole thing was 224 square feet. The whole thing, the whole rectangle, and this piece was 38.5, and this was 38.5, and this 224 again was this whole thing here. So we need to take the whole thing, 224, and subtract 38.5, and subtract 38.5, and we'll have our answer. So let's do that. 224 minus 38.5 minus 38.5 equals, and that equals 147 square feet. And that's our answer. Our green space up here in the problem is 147 square feet. So that's 3 different problems going from easier, going from easier to hard. We're going to happy cat this guy over here. And we're going to spinning happy cat, because boy, that was a tough one. Get him a little dizzy, but happy still. And we will cut back over to our main window, and we're going to, all right, come back. We're going to come back to here. Applause, thank you. Happy studying, and we'll see you in class.